consider applications to be maintainable? Quick show of hands. I'd really like to talk to people who did not raise their hands right now. I think that maintainability is the most important thing developers should be aiming for and care about. It opens up doors to everything else we want to achieve. If your application is maintainable, you can make changes to it really quickly. You can keep your business owners or your product managers happy by being able to quickly add new features. You can also remove features or change how something works without too much sweat on your end. And at the same time, you can keep yourself and your fellow developers happy by working in a code base which just doesn't feel like a dumpster fire. A code base where technical debt is under control. A code base which has predictable, well-understood behavior and dependencies. A code base where you can rely on the same business logic being done the same way everywhere, as opposed to in four different ways in 4 different places. A code base which is super easy to test automatically, so you can have high confidence when you're shipping it. A world where you as a maintainer feel happy, not frustrated, to work on it. And an application that you can offer to your customers with pride and confidence. And it goes even further. Lack of maintainability will really hinder your ability to grow and scale. You simply won't be able to achieve maximum scalability and performance with an application that you're scared to touch, or which simply cannot be modified without a significant rewrite. So maintainability really is the holy grail of good software design. So this brings us to the focus of my talk, which is good software architecture which ensures maintainability. This building is a concert hall in Reykjavik in Iceland called Harpa, where we had our GopherCon EU last year. And the clue to the name of the one particular pattern that I want to talk about today is in this building. It's hexagonal architecture. It's actually the unofficial name. It's the more common name for the ports and adapters architecture, which was described by Alistair Cockburn on his blog in 2005. He was not the only person to come up with the idea. As early as 1992, Ivar Jacobson published a pattern called the BCE, Boundary Controller Entity, or it was later renamed to EBI, Entity Boundary Interactor, in his book on object-oriented software engineering. He is the godfather of object-oriented programming. Then Alistair Cockburn published his blog post on the ports and adapters idea in 2005, giving it the alternative name of hexagonal architecture, which is what it then became more commonly known as. Around 2008, Jeffrey Palermo independently came up with a very similar pattern, which he called the onion architecture. And then Robert Martin, Uncle Bob, he referenced all of those ideas and a few other ones in his book on clean architecture. But actually, he referenced some of those ideas much earlier on his blog in 2011 and 12, when he was talking about the screaming architecture and the clean architecture. So this very same idea kept being reinvented under different names and talked independently over so many years. So maybe that's a clue that it's a good one. So I thought I'll talk about the hex architecture simply because an image of Harpa is a little bit more captivating than an image of a bunch of onions. And also onions make you cry. Hex architecture doesn't. So this is a diagram illustrating the ports and adapters architecture. It shows that an application is composed of 3 layers. The core layer, which is right in the center, is the domain layer. It defines all the business logic of our application. No other layer is allowed to contain any business logic, just this one layer. The domain layer is, on the other hand, not allowed to be aware of any implementation details. Everything to do with how the business logic works needs to be defined in abstract terms and implemented in the outer layers. A common choice is to define your domain logic using domain-driven design. The application layer is the glue between your business logic and the very specific details of how your application communicates with the outside world. It receives the raw input from the framework and does whatever is required to translate it into a form understandable by the domain to perform the operation that we want it to perform. For example, it may unmarshal the request body and maybe validate all the values before passing it into the domain. It will then receive the results from the domain layer and translate them into whatever format is expected by the outer layer. So this could be returning a specific response format or maybe data in the format that is expected by the database. The framework layer is the furthest from the domain, and it's both the most abstract and the most detailed. It treats the rest of the application as a black box, which just accepts some input and then returns a response. It sees them as generic request and response objects, nothing else. It doesn't know anything about how the application works. It's, however, full of specific implementation details for all the external interfaces that the application deals with. The framework layer needs to understand the HTTP protocol or how to establish a connection to a particular flavor of a database, something the rest of the application doesn't really care about. So the first thing that the hexagonal architecture makes you do is think about the different parts that form your application. We start distinguishing between the parts that form the core of your domain versus all the external inputs and outputs. The key difference between this approach and the layered model is that we focus here on the relationship between the inside and the outside of your application, as opposed to the left and right or top to bottom view, which you end up when you think about your application in terms of models, views, and controllers. In the hex model, all the inputs and outputs are just treated as external application adapters to your application. We typically have primary actors, which drive the application. So that could be your users, other systems on the internet, or maybe your automated test suite. And we also have secondary actors, which are the ones being driven by your application. So that could be your database, maybe other things on the internet, like other cloud services or mailbox services, or maybe other systems, other services within your system. Traditionally, to distinguish between those primary and secondary actors, we put the primary ports and adapters on the left-hand side and the secondary ones on the right. So how does this help us achieve maintainability? The key rule in this model is that dependencies are only allowed to point inwards. What do I mean by that? When we think about the requests coming from the outside, the dependencies are a little bit easier to visualize. The outer layers can call anything they like from the inner layers, and they can reach out to the domain as much as they like, but they cannot reference anything outside of themselves. For dependencies going out, like calling the database, we use dependency injection or inversion of control. This is a quote from Craig Walls explaining dependency injection, or DI as it's commonly abbreviated. He said, traditionally, each object is responsible for obtaining its own references to the objects it collaborates with, so its dependencies. When applying DI, the objects are given their dependencies at creation time by some external entity that coordinates each object in the system. So in other words, dependencies are injected into the objects. Inversion of control uses interfaces to achieve dependency injection. So the domain will define all the functionality it requires from external dependencies in abstract terms as interfaces. It will then accept those interfaces in its constructors and call their functions throughout the operation as if they were just some black boxes that do the stuff that it needs doing. The actual concrete implementations of those interfaces will be passed in at runtime. But the domain doesn't really care what they are as long as they satisfy the required interfaces. So that way we can keep the dependencies pointing inwards only. The domain will not need to call out to the application or framework layers because it defines all the interfaces within itself. And this in turn allows for maintainability. Because of this organization of dependencies, we can easily change one part of the application without affecting the rest of it. The point is to keep the changes local. If the domain needs to change, we shouldn't really need to touch any of the outer layers, as long as the interfaces between them stay the same. If the application or the framework needs to change, then we shouldn't really need to touch the business logic, as long as all the interfaces defined at the boundaries are still satisfied. So for example, if we wanted to swap out a MySQL database for a NoSQL store, or an HTTP interface for a command line interface, the core domain shouldn't really need to change. It shouldn't really care about what database is being used or how is the data being saved. It just needs to be able to pass the data somewhere to be saved. And the hex model recognizes exactly that, and it really leverages the power of abstractions or interfaces. It helps keep everything under control, and it prevents the business logic from leaking all over the stack. We define interfaces at every boundary. Interfaces are ports, just like the ports on your laptop, which allow different inputs to be plugged in. Any device which understands your laptop's port can be used with it. For example, any headphones with a jack cable would work when you plug them in the jack port. Or wouldn't they, Apple? That gives you the flexibility to use many pairs of headphones over time without having to buy lots of dongles or change your laptops every time. So each layer will define its ports or interfaces, and then the outer layers will provide adapters for those defined ports. And this is really why the architecture is called ports and adapters. It's also worth pointing out that the hexagon is a random choice. The idea was that each vertex will represent a port, so in reality, the shape will depend on how many ports your layers expose. Alistair Cockburn chose a hexagon because he felt that it leaves enough space on the whiteboard to then write the names of all the ports into a diagram as you're designing your system. He reckons we typically have about 3 to 5 ports in our applications. There is no strict definition of what a port really is, other than it's just an abstract API exposed to the outer layers. So you could have a pentagon, for example, or a square. Or the actual representation of your system could probably look something like this, because there is no rule that every layer needs to implement the exact same number of ports. And then this architecture works equally well for single monolith services or microservices. There is no real difference here. Hexagonal architecture corresponds well to the test pyramid. We can put lots and lots of unit tests in the domain layer because the discrete units of domain and the business logic should be really easy and really cheap to test. Unit tests are cheap to write and fast to run. So it makes sense to focus them on the domain so that our business logic is well protected and tested often. Then the further we go from the center, the more high level we want to get. So the application layer will mostly use end-to-end tests or integration tests, because at this point we're interested in testing the end-to-end behavior and the domain working together with the application. And finally, we can add some tests which drive the application through the user or the command line interface. But because they're slow to run and fairly brittle and expensive to maintain, we don't have too many of those. And we certainly wouldn't expect them to cover every possible scenario. Most things in the framework layer, like the HTTP router or the database adapter, they will probably come with their own unit tests. So there's no need to unit test them ourselves. We can probably just rely on the UI tests or the integration tests to verify that they work as expected. We already have interfaces in place because of dependency injection. And because those interfaces should define dependencies which don't contain any business logic, then any test doubles that you might need to use, they should be fairly simple. Whether you end up having to use mocks or not, it will depend on what your rules, and I kind of mean personal rules, are exactly. If we were to be very, very rigorous about the domain having no knowledge of where the data comes from or where it goes to, then it won't really be calling any functions to save to the database itself. It will be the application layer that will be in charge of deciding where the data goes and what happens to it once it receives it or passes it into the domain. So the domain layer is purely focused on data processing. So in that case, in theory, you shouldn't have anything to mock out in the domain unit tests. And then if you mostly write end-to-end tests in your application, in the application layer, then there is no need to mock there anything either because you actually want to use the real database then. Real life, however, sometimes has your domain calling out some dependencies through their interfaces directly. So, for example, when you want to fetch an existing object before updating it and just cut that corner. So in this case, you just have to mock that call out. And I've never been a fan of the always or never do things rules. So I think in some cases, it's just fine to do. Hexagonal architecture will naturally encourage you to have lots and lots of unit tests, some end-to-end tests, and a few UI-driven tests. At every layer, an automated test framework is just another adapter to your ports. Let's put it all together. Hexagonal architecture introduces structure and consistency into your project. It's easy to navigate, it's easy to understand, and it's easy to reason about. Use case-centric architectures tend to make sense to people. And maybe this is why we keep coming back to this idea under different names. The Hex architecture makes your applications easy to change, because the inside and the outside layers are loosely coupled. It supports evolutionary design, because there's no limits to how many ports you can have. It makes your code easy to test. And the design of your code will reflect exactly how the application works. If something is placed in the application layer, then you know that it most likely will provide some sort of service for handling requests, and that it won't define any business logic. The responsibilities of each component are clear, depending on where they are. And the structure of your code, how your files are actually organized on disk, it will follow that design exactly. In any application, the code is ultimately the most up-to-date documentation of your business logic. Sometimes the intended design is not actually how the application works. So in the Hex architecture, we minimize the risk of that happening by keeping the core domain logic in one place, making it reusable, and very testable. There is no single right answer to code structure. End of the day, it's whatever works for you and for your use case. Sometimes the Hex architecture might not be the right choice, and that's fine. But if you don't know where to start, especially for a biggish commercial project, I think it's a good one to try out. Or maybe you can start out with a flat structure and then move over to the Hex architecture over time. Remember that the logic in your application will expand and it will change and morph over time. So almost don't expect to get it right the first time. As Bruce Lee said, be like water. Expect to change and adapt over time. Whatever you do, aim for maintainability and don't overcomplicate your structure. Keep it as simple as possible, but no simpler. Go for the simplest solution for today and don't worry about the future. Prototype and experiment. It will help you raise questions you didn't even know you should be asking. Remember that good choices and best practices come with experience. So play around with your code and share your ideas with the rest of the community. We've seen the idea of ports and adapters being reinvented so many times, but I'm sure there's plenty more to discover. Thank you.